Hello students, welcome back to Organic Chemistry. In the last lecture, we have seen how to name the organic molecules with double bond, triple bond in them. In today's lecture, we are going to learn the nomenclature of different organic molecules with different functional groups in them. So let's get started. The first set of molecules we are going to name here are haloalkanes. As the name suggests, they have halogens in them as functional group. The different halogens are fluorine, chlorine, bromine, and iodine. From alkane molecules, when the hydrogen is replaced by any of these halogens, then we call them as haloalkane molecules. There are two ways of naming these haloalkane molecules. One is common name. The common nomenclature or the trivial name is always alkyl halide. This is the general name. And the iupac nomenclature, the standard way of naming these molecules, it is haloalkane itself. Let's take some examples and understand this. Now, we'll do both the common nomenclature and iupac nomenclature as it is important for your board as well as competitive exams. Now, there is only one carbon, therefore the alkyl part will become methyl. So you have to call this as methyl. And what is the halogen here? Fluorine. Therefore, we have to call this as fluoride. Methyl fluoride is the common name. How about the iupac name? It's a haloalkane. What is the halogen here? Fluoro. That is fluorine, right? So fluoro, and there is only one carbon, therefore fluoromethane, like this. Now, if there are two carbons, right, like CH3, CH2, and there is a halogen that is chlorine here, and the common name would be ethyl because there are two carbons and the halogen is chlorine, therefore ethyl chloride. And the iupac name is chloroethane. It's as simple as it is. Now, let's take a molecule with 3 carbons, and the position of chlorine is important here, right? Because look at this, the chlorine can be attached at the first or second carbon. Therefore, what do we call this as? We call this as 1-chloropropane. That is the iupac name. What about the common name? Since it is the longest chain of carbons, right? So it's a simple long chain of carbon. Therefore, you can call this as N-propyl chloride, like this. The isomer of this molecule is something like this. That means what? They have the same formula, but the position of the chlorine is different. Since there are two methyl group attached to this carbon, we can call this as iso, right? As I told, it's isomer, right? Therefore, isopropyl chloride. That is the common name. What about the iupac name? It's better to number the longest chain of carbons and make sure that the halogen attached carbon will get the least possible number. So here in this case, however you do it, either from left to right, right to left, this carbon is going to get the second number. Therefore, it will be 2-chloropropane. You don't have to start numbering from this carbon, okay? You should always choose the longest chain and give the least possible number. Therefore, it will be 2-chloropropane. Now, let's write down some more bond line structures for the haloalkane molecules and name them. For the given molecules, let's give the common names first. Since it is the longest chain and there are 4 carbons, we can call this as N-butyl chloride. Here, the carbon attached to the chlorine is secondary. Therefore, you can call this as secondary butyl chloride. That means what? Whenever an alkyl halide is having 4 carbons, we always call it as butyl chloride. It's just the prefix is different. So here it is N, here it is secondary. Now, there are 2 methyl attached to a carbon. That means what? We always call this as iso, and it is isobutyl chloride. Like this, right? And now, the chlorine attached carbon is tertiary. Therefore, we can call this as tertiary butyl chloride. For the next molecule, count the number of carbons 1, 2, 3, 4, 5. That means it is a pentyl chloride. You can write that first. And then you see here, this carbon is attached to 2-methyl. So whenever we have such group, right, like this, always use the prefix iso, right? Therefore, it will become isopentyl chloride. If there are 6 isohexyl chloride, so this is the iso group. Now, we have a tertiary butyl, but it is attached to a carbon here, which is a primary carbon. So, in that case, we are going to use one more prefix called as neo. And there are 5 carbons, therefore it is a neopentyl chloride. Like this. These are the common names. Now, let's give the iupac name. For iupac nomenclature, choose the longest chain, right? Here the chlorine is at the first carbon. Therefore, you have to name it as 1-chlorobutane. Like this. For the second molecule, choose the longest chain, right? You number it in such a way that the chlorine carbon will get the least possible number. Suppose if I would have numbered from here 1, 2, 3, it would have been 3-chloro. That is wrong. Therefore, we have to call this as 2-chlorobutane. Now, there is a branching, therefore, choose the longest chain carefully, right? And make sure that the carbon attached to the functional group, that will get the priority. Remember, methyl is not a functional group, it's an alkyl. Therefore, you arrange this chloro and methyl according to the alphabetical priority. So, don't forget that 1-chloro, 2-methyl. Not because chloro is a functional group, okay? It's just the alphabetical priority because both of them are prefix. Therefore, 1-chloro, 2-methyl propane. Now, for the next molecule, choose the longest chain. See, I can't number from here 1, 2 because that is not the longest chain. So, either you take like this 1, 2, 3, 1, 2, 3. Doesn't matter. So, now chlorine and methyl are at the same position. So, 2-chloro, 2-methyl and propane. Now, let's take the next molecule. See here, choose the longest chain. The chlorine is at the first position. Therefore, 1-chloro, 3-methyl. Longest chain is having 4 carbons. Therefore, butane. That is the root word and suffix. Now, for the last molecule, 1, 2, 3, right? So you can take it this way also 1, 2, 3, 1, 2, 3. Either way, it will be 3 carbons in the longest chain. And the chlorine will get the alphabetical priority 1-chloro. But at second position, there are 2-methyl. Therefore, you are going to call this as 2,2 dimethyl. Dimethyl. And there are 3 carbons, therefore propane. This is the iupac name of the neopentyl chloride. Now, let's name the alcohol molecules. Alcohols are the molecules with OH as functional group in them. Generally, we write the molecules as ROH. The trivial name for the molecules could be alkyl alcohol. And the iupac name would be alkanol. So depending on the number of carbons and the alkyl chain, we give the names to the molecules. Again, Knowing the common names and the iupac names are important for your exams. Now, the first member of alcohol family is methyl alcohol. And iupac name of this molecule is methanol. So from alkanes, the E is replaced by ol. So methanol, right? That is the suffix. So if there are two carbons, right? So we are going to call this as ethyl alcohol. And the iupac name would be ethanol. If there are three carbons like this, and it is a longest chain without any branch, therefore you can call this as N-propyl alcohol. And when it comes to iupac name, it's always better to number the longest chain like this. And where is the OH? At the first position. Therefore, you are going to call this as 1-propanol like this. If the OH is at the second position, right? So methyl are attached to the carbon. Therefore, you can call this as isopropyl alcohol. And what about the iupac name? Like this. It's supposed to be 2-propanol. You can also write as propan 1-ol for 1-propanol molecule or propan 2-ol for 2-propanol molecule. The nomenclature of alcohols is quite similar to that of the haloalkane molecules. How so? Just observe here. The common nomenclatures for the given molecule is, say, here we are going to call this as N-butyl alcohol because there is no branching. Here we are going to call this as secondary butyl alcohol, right? And here it will be isobutyl alcohol. I'm just writing it as ALC. It's understood that it's alcohol. Same here also, tertiary butyl alcohol, right? So now look at this. This is neo group. But how many carbons are there? 1, 2, 3, 4, 5, 6. Therefore, you are going to call this as neohexyl alcohol, right? What about here? 1, 2, 3, 4, 5, 6, and 7. And this is iso. Therefore, isoheptyl alcohol. Students, remember one more thing, not all alcohols will have the common names, right? So some molecules you cannot do the common nomenclature. That's why we always follow the iupac nomenclature. For every molecule you can give iupac nomenclature, but not the common names. You remember that. Okay. Now let's do the iupac nomenclature. So this is going to be 1-butanol. Simple. Here it's going to be 2-butanol. Now here, sorry, here it's supposed to be OH. Make that correction. Okay, not a big deal. So now it's going to be 1-propanol. Okay, so at second position there is a methyl. Therefore, 2-methyl and the OH is at the first carbon. Therefore, 1-propanol. Okay, now choose the longest chain. You see at second position there is a methyl. Therefore, 2-methyl and second position there is a OH. Therefore, 2-propanol or propan 2-ol. However, make sure that you will give the hyphens properly. Now, choose the longest chain. Make sure that the carbon attached to OH will get the least possible number. Okay. Here it might not obey the lowest sum rule. Like suppose if I would have number from here 1, 2, 3, 4. The methyl groups would have got the second number. But important here is functional group. That's why. Okay. So therefore it will be 3, 3 dimethyl. And it is butanol. And at first position there is a OH. Therefore 1-butanol. 1-butanol. Now, let's take the last molecule like this. At fifth position, we have a methyl, 5-methyl. And this time we'll write like this, hexane, 1-ol, 1-hexanol. Many students make a mistake of writing hexol. Okay, they will not write the AN here. So don't do that. 5-methyl hexane 1-ol. That is the correct iupac name. Now let's learn the nomenclature of aldehyde molecules. So the aldehydes are the organic molecules with CHO as a functional group. For aldehydes, the iupac nomenclature is very important and the general name of these molecules is alkanal. The common names for certain molecules it is important but not for all of them. So let's start naming some of the molecules. So the first member of aldehyde molecules, it's formaldehyde. That is the common name. So formaldehyde. And the iupac name of the molecule is methanal. The al refers to the aldehyde functional group. Now, the higher homologue of the molecule is ethanal because there are 2 carbons. The ethanal is also called as acetaldehyde. Formaldehyde and acetaldehyde are very common names used in organic chemistry. So you have to remember that. Now, the 3 carbon containing aldehyde, so we call this as propion aldehyde. So easy to remember, okay? Propion aldehyde. So you can also call it as propionaldehyde, right? So the iupac nomenclature is propanal, right? So if there are 4 carbons, say like this, 1, 2, 3, 4, right? That means what? The aldehyde is always terminal, the functional group, because the functional group contains carbon. That's the reason. So we call this as butyryl aldehyde, right? So it's called as butyraldehyde, or the iupac name is butanal. As I told earlier, for aldehydes molecule, the iupac nomenclature is quite important. Always choose the longest chain of carbons and start numbering from the functional group because the functional group carries carbon. That is the reason. Now, since there are 5 carbons, you can call this as pentanal. No substituents for this particular molecule. But for the next molecule, you can see there is a substituent, there is an alkyl, and that is at the 3rd position. Therefore, it's a 3-methyl butanal. You don't have to write butan 1-al because it's understood that it is at the 1st position. Similarly, for the next molecule, always start numbering like this, right? Although it looks like this is the longest chain, but this is the longest chain. So now, at the 2nd position, there is a methyl. Therefore, 2-methyl pentanal. Now, the longest chain here is this, right? But it doesn't include our functional group. Therefore, it cannot be the longest chain. The longest chain is supposed to be this. And number from the aldehyde functional group. That is the difference between the previous molecules and this one, right? So now how do you name this? At the 2nd position, 1, 2, 3. That means what? A propyl group is present. Therefore, 2-propyl pentan 1-al or pentanal simply. So this is how we name the aldehydes. Now let's name the ketone molecules. Ketones are the organic molecules where the carbonyl functional group is planked between 2 alkyl or aryl groups. That means what? We need minimum of 3 carbons to form a ketone molecule. The general name for the ketones is alkanone. There are different ways of giving the trivial or common names for ketone molecules. The first member of ketone family is acetone. That is a common name, right? It is also known as dimethyl ketone. That is the other trivial name. But the iupac name, there is only one. So that is propanone, like this. The higher homologue of acetone is butanone, right? So butanone. You can also call this as ethyl methyl ketone. Okay, so ethyl methyl ketone is the common name. If there are 5 carbons like this, you can either call it as diethyl ketone, or you can give the numbers to the longest chain and then you can call this as 3-pentanone. You don't have to start numbering from the functional group carbon like aldehydes. Okay, here it is different. Here you will have carbon of the functional group in the chain of carbons, right? That's why you have to number it from one end to the other end. Make sure that the carbonyl carbon will get the least possible. Therefore, here it's going to be 3-pentanone. The iupac name of the first molecule here is, it's a 2-pentanone. How so? Choose the longest chain of carbons. Make sure that the carbonyl here will get the least possible number. Similarly here, like this, but I would prefer numbering from this position so that the functional group will get the second number. Therefore, it's going to be 3,4 dimethyl, and you can also name it like this, hexane 2-one or 2-hexanone. Either way it is correct. Now, this is tricky. Although this looks like a longest chain, that is not correct. You have to start numbering from here, right? So this is the longest chain, like this. So the methyl here is a substrain, not the main chain. So at third position, there is a methyl, hence 3-methyl, right? And heptane. At second position, there is a ketone, heptane 2-one or 2-heptanone. Either way it is correct. Similarly here also, like this. If we number from here 1, 2, 3, 4, 5, and this will not get the least possible number. So that is not correct. So the correct way of numbering is like this. So this will be 4-methyl. 4-methyl heptane 3-one. So this is how you name the ketones. Now let's take the carboxylic acid molecules and name them. Carboxylic acids are the molecules with COOH as a functional group. The general name is alkanoic acid. That is a iupac way of naming the molecules, like methanoic acid, ethanoic acid, propanoic acid, depending on the number of carbons. But what about the common nomenclature? The common nomenclature is very important for carboxylic acids, and the first member is called as formic acid. Similar to formaldehyde, there the aldehyde is the functional group, here acid is the functional group, and the iupac name is methanoic acid. The numbering is similar to that of the aldehydes because both aldehyde and carboxylic acid have carbon in the functional group. So now the next molecule is acetic acid, which is nothing but ethanoic acid. That's why it's important to remember the general name. Now, with 3 carbons, we are going to call this molecule as the common name. First, we'll see the common name. It's called propionic acid. Propionic acid. But the iupac name is propanoic acid. Propanoic acid. With 4 carbons, all right, it is butyric acid. Butyric acid because it is assumed to be present in butter. That's the reason, okay? So it's the iupac name is butanoic acid. So always we number from here. So we don't have to write it as one propanoic acid, one butanoic acid, because by default it's going to be at the first position. That's why. Now let's take some more examples and give the iupac names only. Now let's name the given carboxylic acids. First, number the longest chain and start numbering from the functional group as it contains carbon. At second position there is a methyl, hence it's going to be 2-methyl butanoic acid. Butanoic acid. Now, for the second molecule, make sure that you will start numbering from the functional group, right? Although this is the longest chain, right? So this will become the substrate, hence it's going to be 2-ethyl pentanoic acid. Pentanoic acid. Similarly, for the next molecule, there are two alkyl groups present. Hence, arrange the prefixes according to the alphabetical priority. So 2-ethyl, 3-methyl. In the longest chain there are how many carbons? 5. Therefore it's going to be pentanoic acid. Pentanoic acid. Now, although this molecule looks complicated, we just follow the rules what we have discussed. Start numbering from the functional group. This is not the longest chain. This will be the longest chain. Look here. Although this looks like a ethyl substrate, but this comes in the longest chain. Now, what all substrates we have? Ethyl, and there are 2-methyl. So, according to alphabetical priority, ethyl will come first. So, 2-ethyl. We should not take the D of dimethyl for the priority. Remember that. All right. So, 3,5 dimethyl. Dimethyl, and there are 7 carbons, hence it's going to be heptanoic acid. Yes, this is how we name the carboxylic acids. Now let's name some of the derivatives of carboxylic acids like esters and acid chlorides. Now let's name the esters molecules. What are the esters? The molecules with the COO functional group in them, where the carbon oxygen there is a double bond and then there is a single bond. Generally, these are named as alkyl alkanoid. The iupac nomenclature is important here. So this is alkyl part, right? And this is the alkanoid part. So you just remember this much. It would be easy for you to name the molecules. So first we need to name this part. So that means what? This is methyl. Methyl. And then there are 2 carbons here. Therefore, it's going to be ethanoid. Let's take some more molecules and make sure that we will learn it properly. Now, here we have ethyl group. Therefore, ethyl ethanoid. Here we don't use alphabetical priority for the alkyl alkanoid. Okay, it's always first the group attached to oxygen. Next, see here, there is 1 carbon, so therefore it's going to be methyl, and here 1, 2, 3, therefore ethanoid. Let's take one more example, something like this. Now, you see there is a methyl here also, but you should never call it as dimethyl. That's wrong. So that means what? First you name this part as methyl and then number the longest chain from here. Remember, the oxygen is placed in between the carbons. That means what? This cannot be the longest chain, right? So you should start from this carbon. So 1, 2, 3. Now at second position, we have a methyl. Therefore, 2-methyl. That's why we don't write a hyphen between this methyl and this 2-methyl. So that shows it is an ester. Okay, this is very important. So methyl, 2-methyl, and how many carbons we have here? 3. Therefore, propanoid. So this is how we name the esters. So let's see how to name the acid chlorides. Students, among the acid halides, acid chlorides are the one which are quite popular. So let's name these acid chlorides. The general name is alkanoyl chloride. Alkanoyl chloride. So what is the functional group? The functional group is RCOCl. So that means what? The whole group RCO is named as alkanoyl and this is the chloride. So let's start from CH3COCl. We don't have HCOCl because it's not stable. So we start from CH3COCl and you see there are two carbons. Therefore, the alkanoyl will become ethanoyl chloride. It's as simple as it is. Now we can start with more number of carbons, 1, 2, 3. So it's going to be propan, right? This is the root word oil chloride. That is the suffix. Now, what if there is a substrate like this, right? So as usual, you number the longest chain like this. At second position, there is a methyl. So write it as 2-methyl. And then we have how many carbons? 4 carbons. Therefore, butanoyl. Butanoyl chloride. So you apply the same rules for any given molecules and you will get the right names. Now let's see how to name the amides. Amides are the organic molecules with functional group RCONH2 like this. So the general name would be alkan amide. Right? So how do you name this now? Look at this. There are 2 carbons, hence it's going to be ethanamide. Ethanamide. And if it is like this, so 1, 2, 3, therefore it's going to be propanamide. And if there is any substituent, right, say maybe like this, then what you do, start numbering from the functional group carbon. At third position there is a ethyl, therefore it's going to be 3-ethyl pentanamide. So here I'm going to discuss the last set of molecules. They are ethers. Ethers are the organic molecules with the functional group ROR, and generally the iupac nomenclature would be alkoxyalkane. So which is the alkoxy? The alkoxy part is the one with the less number of carbons. If the chains here R and R have different number of carbons. If they have same number of carbons, then there won't be any problem. You can just call it like this. So say for example here it's going to be methoxy. So no ambiguity in this case. So methoxy methane, right? What if the ether is unsymmetrical? That means the substrates are different. Then the one with the less number of carbons is taken as prefix. Therefore, it's going to be methoxyethane. Right? Say for example, if you have something like this, then how to name this? No problem, you choose the longest chain containing only carbons. Then what about this? This will be always a prefix. So you see at second position the prefix is present. So that is nothing but 2-methoxypentane. Now I'm going to give you one more molecule. Maybe for this you can predict the iupac name of the given molecule. Comment the name of this molecule in the comment section. Thank you for watching this video. Until next time.